Okay, so question 4. Okay, we're going to apply Newton's second law. The driving force of the car would be that direction. The whole system, the force equals mass times acceleration. So what have we got? The driving force in the opposite way. We've got 900 and 700. Sorry, no, that's the weight. We've got 300 and 100 equals mass times acceleration, and our mass is 700 plus 900, and our acceleration, they've said, is 1.5. So D equals 400 plus 1600 times 1.5. So you should have that D equals 2,800 newtons. Okay. Right, calculate the force in the coupling. Well, it's this little bit here. So you're looking at the individual system just on this little bit here, because the tensions will be the same, but in different ways. So the force in the coupling, that way, we're still going to use Newton's second law, equals mass times acceleration. So what we actually have is T minus 300 equals mass 700 times 1.5, and you should get T equals 1,350 newtons. Okay, nice 5 marks. Right, question 5. Acceleration of a particle of mass 4 kilograms is given by A equals 9I minus 4tj. Find the acceleration when t equals 0 and when t equals 3. So when t equals 0, A equals 9I, and when t equals 3, A equals 9I minus 12j. And that's really all they're asking for. Right, calculate the force acting on the particle when t equals 3. So we know our acceleration, we've done that in the first part. We're going to use this bit here. Okay, and we know the mass is 4 kilograms, so F equals ma. So it's 4 times 9I minus 12j, which is 36I minus 48j. And you can leave it just like that. Oh, and newtons. Don't forget the units. Oops. Okay, so the particle has a velocity 4I plus 2j when t equals 1. Find an expression for the velocity of the particle at time t. So we need to remember that velocity equals the integration of the acceleration, because acceleration equals dv by dt when you differentiate velocity. So we need to go back the other way. So we've got velocity is the integral of 9 minus 40 dt. So you'll get 9t plus 1 constant minus 4t squared over 2 plus another constant, we'll call that d. Okay, when t equals, what's it saying? When t equals 1. So when t equals 1, we've got that the velocity is 4I and 2j, and it's equal to 9 times 1, putting 1 in here, plus c, over, obviously that makes it minus 2 times 1 squared, which is still 1, plus d. So we've got a pair of simultaneous equations. Right, let me change this to red. We've got 4 equals 9 plus c. Therefore, c equals minus 5. And we've got 2 equals minus 2 plus d. Therefore, d equals 4. So we can actually write it as, give running out of places here. We just go down here. V equals 9t minus 5i plus minus 2t squared, and d was plus 4j. Or you can rearrange it the other way around. And that's it. Meters per second. Okay. Right, question 4. A car is driven with a constant acceleration a along a straight road. Its speed when it passes the road sign is u. The car travels 14 metres in the 2 seconds after passing the sign. 5 seconds after passing it has a speed of 19. Write 2 equations connecting a and u. Hence, find the value of a and u. 5 marks, and there must be quite a lot of work for this one. Okay, so it's talking about distance. Let me change my pen so you know which one I'm doing. Okay, it's talking about a and it's talking about time. So I think we need to think about s equals ut plus a half at squared. So part 1, s equals ut plus a half. Whoops, goodness me. Half a t squared. Okay, so given its constant acceleration a, speed point it passes a road sign is u. Okay, so that's u. We're going to just leave that in there, and the car travels 14 metres in the 2 seconds after the sign. So here's the sign. There's my sign at u, and it goes 14 metres. So if we have t equals 0, t equals 2. And 5 seconds after passing the sign, it has a speed of 19 metres per second. So I don't know how far it's gone, distance, but I know that t equals 5. Okay, and v at this point is 19 metres per second. Okay, so I know the distance and the time at this point, and the time and the velocity at this one, but not the distance. So let's have a look at what we've got. So we've got, we know that, looking at part 1, 14 equals 2 seconds, so 2u plus a half a, and 2 squared is 4. Okay, so we've got 14 equals 2u plus 2a. That's for the first bit, for the first 2 seconds. So there's one equation, and I suppose I could say, well, 7 equals u plus a, if I wanted to make it easier. Right, the second bit, I know the velocity, and I've got the time and the acceleration, so I'm going to use, for the next bit of it, I'm going to use v equals u plus at, because I know that it's doing 19 metres per second at this bit equals u plus 5a, sorry, because the time is 5. And we know the acceleration is a, so that's my second equation. Okay, so can I get an overall equation from this? I've got 14 equals 2u plus 2a, that's 1, and 19 equals u plus 5a, that's 2. So if I multiply this one by 2, I get 38 equals 2u plus 10a. Let's call this equation 3. And let's do 3, take away 1. And you should get 24 equals 8a. Therefore, a equals 24 divided by 8, which is 3. And then going back in, I get, substituting back in one of the other ones, I will get, sorry, this is all over the place, isn't it? I will get, so put a equals 3 into one of these. I've got, let's have a look. Put in here, 7 equals u plus 3. So 7 minus 3 equals u, therefore u equals 4 metres per second, and that obviously was metres per second squared. Okay, so have we finished the question? Right, so that's part 1. Write down 2 equations connecting A and U. What distance does the car travel in the 5 seconds after passing the road sign? Okay, so we can just put those values in now, because we can do here, part 2. S equals ut plus a half at squared at time 5. So we know that u is 3 from this here. No, u is 4. Talking rubbish. So u is 4 times 5 plus a half times, and a is 3 times 5 squared, which is 20, plus a half times 3 times 25, and you should get 57.5 metres.